Welcome back to my channel. In this video, we're going to be talking about how to use the Oracle merge statement in Python. And as the little panda face indicates, we're going to be using pandas to make this work a lot easier. So let's jump in. The problem we're trying to deal with is what's called database table maintenance. You have, assume, a data warehouse. And a data warehouse really could just be a copy of a table. But the problem is the table will get out of date. Maybe you took a brand new, fresh snapshot a month ago of, say, the customer table, but it's going to get out of date. Customers will be added, customers need to be deleted, and sometimes customer information like address, etc. change. So we need to get that information up to date. Now maybe your table came from an enterprise data warehouse source like SQL Server, Oracle, or Postgres, or whatever, so you'll need to get data from there for the update. Maybe it came from flat files. In this case, it could be logs coming from different applications, or it could just be vendors are sending you files, or whatever the source is. Either way, the goal is you need to get this data into the database where it can be reflected in the master table. So this is really kind of a common pattern known as sort of table maintenance as a transaction processing flow that goes back many, many decades. The idea here is that we're going to take the data from wherever it's coming from, and we want to get ideally just the changes, but if all we have is a snapshot of the table that we need to apply to our master table, that's okay too. We're going to bring it in, and we're going to persist it as a transaction table. It doesn't have to be called transaction, but that's the concept. It's a transaction table, meaning it's going to apply changes to the data. What are the changes it could apply? Could be doing inserts, new customers, could be doing updates, changes like address, or it could be removing customers that just aren't valid anymore. So this is the idea. It's going to make it current. What is the merge statement? It's a SQL statement that can add, change, and delete data. It works off a match condition. All tables in a warehouse should have a unique identifier called a key, right? So we have a primary key, it's usually referred to, and that identifies uniquely each entity. In the case of customers, every customer will have a unique identifier, customer key, so that we know that Brian is a separate customer from Joe or Mary. That's the crucial thing, because we need that key so that when changes come in, we know who needs to be updated, who's new, which means the key doesn't exist yet, or maybe they need to be deleted. So the merge statement can be seen as an all-in-one ETL statement. That's what's so great about it. We can do all of this in one statement. Traditionally, we'd have to use an insert, a delete, and an update statement to accomplish the same thing. So this is nice, and it's actually really easy to read once you get used to the syntax. Let's jump into our code example, which is in a Jupyter notebook now. As always, I warn people, it is not intended for production use. Why do I put that disclaimer besides trying to protect myself? It's to warn you that any code you get from anywhere, you should always test it in a sort of contained sandbox type environment. One that you're not putting anything at risk. You don't know what could be in code. Now, of course, I have nothing malicious, but this is SQL code which could drop tables or even drop entire databases, and you don't want to find out too late that you've done some damage to an important environment. So you want to do it ideally on your own machine in a sort of self-contained, you've got your own little Oracle, maybe test instance there, and you can just work from it. One of the things you're going to need right off the bat is an important package called SQL Alchemy. Now SQL Alchemy is traditionally used to provide services to connect to and use many different types of databases for application purposes. So typically you see SQL Alchemy used a lot in web and mobile apps, not as often when you talk about data analysis. We're going to use SQL Alchemy, but we're not going to use what's most commonly used with it, which is its ORM, which is a object relational mapper. We're not going to get into that because we don't really need that kind of overhead and complexity. We're going to make it really simple because we're interested in data analysis, not heavy-duty transaction processing. To get SQL Alchemy, if you just installed standard Python, you didn't do Anaconda, you're not using that Conda as a package manager, you can just do pip install SQL Alchemy. To do that, just remove the comment before the statement pip install, and you can run it from within your notebook. Or you can do this outside the notebook if you prefer. If you're using Conda, here's the statement to do the install using Conda. Either way, you just got to make sure you have SQL Alchemy installed because we're going to be using that as part of this. The other package you're going to need is the driver. This is the database driver, and it's called cx_oracle. There may be other ones out there, but this is the one I'm using in this, and it's a package that's available as part of Python. So we're going to, again, pip install cx_oracle, remove the comment to do that. Now there's some notes. I have to be honest, I found Oracle to be the quirkiest most difficult of all the databases so far to get to work with Python. And it kind of surprised me, at least the way I'm doing this. And I'll explain that as I go forward. But I put links in here to help you understand some things. But one of the things that was a little tricky was that Oracle doesn't apparently really have the concept of a database, which seemed a little weird when you consider that's what it is. It has to do with how it's architected, etc. But that caused a little bit of confusion when I was trying to connect to the database, and I'll show you that. They have what's called instead a service name. And the idea really could be you could have multiple machines serving together as essentially the database server, and they call that a cluster. And because of that, they kind of obfuscate the idea of having an actual database. Now, to get the service name, I just connected to Oracle from the command line SQL+, and I did a select asterisk from global name, and that came back and gave me what I used, which was just XE. In your case, hopefully if you're using the Oracle database with anything else, you should know what the service name is, but if you don't, I've left some links here also that can help you identify it. Now, to connect to the Oracle database, I'm going to use Python code, but I'm going to do it as a function because I want to make it reusable. And I have not done that in my other videos using the merge statement or in general, but it actually is a good idea, so I would recommend it. I copied the basic code structure for what I'm doing from this link, so you can go and look at that as well. So thank you to the person that wrote that. But I wrapped it in a function. To do this, you're going to need pandas. So I import pandas as PD, and then SQL Alchemy. So I import from that create engine. Create engine is just what we use to get a connection to the database. Now we're going to create our function, which is called get Oracle connection. So self-explanatory. And our parameters coming in are the username, the password, the host name, the port, and the database name. This database name, again, is not actually the database name. It is the instance name. So we'll see that as we get through. Now, what I liked about that blog is it used this Oracle connection string, and it just put the entire format of what we need to do in the string, but put substitutable parameters in these braces. And we can just use a format statement to plug in the values that we passed in above. So here we see we're going to call create engine, which gets our connection, as I said. We're going to pass all these pieces through, but we're doing it with our string format. So by taking it and using format, we're able to very easily plug in the username, password, host name, etc. Host name, I should mention, that's typically what I've seen on SQL Server as what SQL Server would use as more of that high level. It's a server level. So here you just say localhost. That may work for you. You may need to change that to whatever is appropriate for your environment. And the database name is this. So when we actually do this, we're not really giving it a database name because the database, doesn't have such a thing. This is really my installation of Oracle on my machine. That's what it gave it as a service name. I'm going to return conn_Oracle. So that's all it's going to do. That will be the connection itself. And I'm going to do a little print here to just make me feel better that it actually ran this. So I'm going to run this statement. Now I'm going to use it to return an object, conn. That's going to be my connection object. And I'm going to say get Oracle connection. And now this should hold my connection to the Oracle database. I can test it by doing read SQL. The username I'm using is called HR. I use that because that's a built-in username that Oracle automatically provides so that you can play with and learn about Oracle, etc. You need to enable that. There's some links. I think the links above may help you, or just use whatever accounts you have available to use within the database. You need a username and password. But because HR comes with some tables that it's created, you can just test it this way using emp details view. And notice I say where row num is less than 5. Oracle doesn't actually have a limit statement as you have, say, in SQLite. Instead, it uses, the best you can really do is using row num. Row num is a unique sequential identifier for each row that's kind of behind the scenes, but you can query with it. So this gives us an easy way to just limit our rows returned. Again, notice we're using read SQL. So this is from pandas, and then we're running our query, and we pass in our connection object. There are ways to run this query using SQL Alchemy directly in what's called passing like raw SQL. The problem is it doesn't return a data frame, which makes it a lot harder to read. So I like using the read SQL. It's one of the advantages of using pandas. We're going to create our table explicitly. There are ways to do it implicitly, but we're going to do it explicitly, meaning we're going to actually tell it the table definitions we want because we want to have a primary key. And I'll show you what I mean by that and what happens later. But the primary key, as we talked about, uniquely identifies each row so that we can do maintenance on it. Now, Oracle does not support an if exists. I was actually kind of surprised because most databases do now. And what I mean by if exists is that when I do something like drop a table, I can usually just add a phrase in here said if exists and then the name of the table. And that would tell the database to only drop the table, only attempt to do that if it exists. So we'll check the catalog and say, yep, that table exists, and do a drop. The reason you want to do that is because you want code to be rerunnable. You don't want to get error statements when you run a statement like this if the table doesn't exist. So what I'm going to do instead is do a try statement in Python. Try is a way to sort of trap code so that you can trap errors. And so we're going to say try to do this, and we'll run this statement. If it fails, it will run this part to handle the error, the except clause. And then we can have our statements here, which is just going to tell us the table doesn't exist. It actually triggered an error, but we've trapped it. That's all that's happening there. So I'm going to run it. And just to show you, notice no problem there. But if I try it again, it says table does not exist. So it trapped the error, and I don't get an ugly dump of error messages. I'm going to do the same thing here. And what we've done is we've created our master table, which is YouTube customer, and our transaction table at YouTube custtrans. So you have a complete end-to-end demonstration of how to do this. We're creating our table now, YouTube customer. Let's walk through this a bit. We've got our customer key, as I mentioned, and we're going to create an integer for that. We're going to tell it it's a primary key and it's not null. You don't allow nulls, obviously, since you need this to identify who this customer is. So it's critical you have that column. Then we have a last name, birth date, which we're making a date. This is just a varchar too. That's the varchar for oracles. That's kind of their format. Char, this is marital status. Integer yearly income. Now integer actually is coming in as a decimal place, but the decimal value is always 00. So I'm just going to force it to be an integer. And we have a modified date as a date. And then I'm adding this extra column, ETL last update. Why am I doing that? What is that? This is sort of a best practice if you do ETL work, and I've done it a long time. I always include at least one, sometimes two columns to tell me when was this row last updated, and sometimes an extra column to say when was it first inserted. So then I know, okay, this customer was added 2 years ago and was last updated, say 6 months ago. It's kind of nice to know that. It's worth the overhead of putting that in the database. DBAs don't like extra space taken up, but for ETL purposes, you really need that. But we're going to just use the one column. This just says when was it last updated, which could be the first insert date, in which case it will default automatically to the current timestamp, and we don't actually have to give it a value for that. But if it's an update, we'll just replace whatever it was inserted with on that date time. So I'm going to run this create table statement. One other thing I should point out, you'll notice everything's lowercase. Oracle is a bit of an interesting way of handling case. In the one hand, it typically Oracle runs on a Linux environment, and it would be case sensitive. But Oracle's default settings is to try to not be case sensitive. So it will actually return all of your object names. It will actually return all of your table and column names as all uppercase, which may seem strange because you may not have created them that way, but it kind of just treats everything as uppercase. I'm kind of doing the opposite in my creation. I'm using all lowercase, so I don't cause any confusion with Oracle. But when I were to query the catalog using at least SQL tools that Oracle provides, then I'll see uppercase. So don't be surprised when you see, why is it doing all uppercase? Okay, so we're going to do the same thing now with custtrans, and you'll notice again, same key, because we're going to have to match on that key, right? And we want it to be index, which creating it as a primary key will do, so we'll get better performance. Got a last name, birth date, marital status, all this stuff. The other extra column we have is called an action indicator. Now I really threw that in to make it easier to walk you through what I'm doing. What's an add? What's a change? What do I expect this to be doing? Most of the time you may just have a snapshot of the table or partial snapshot with just changes that you need to apply. You don't have to have the action indicator, but it's nice for auditability. I have done things like this in cases where there's a complex ETL process, and I sometimes will create explicit transaction tables with an action indicator like this for auditability, so I can look back and say, oh, that was supposed to be an add, that should have been a delete, and also to clean things up. Like maybe I have 3 different updates to the same row. Well, I can consolidate and say just do one update. I don't need to do 3 snapshots or 3 updates on the same row. By the way, the merge statement will fail if there are more than one row trying to do an update on the same key. So you're going to have a problem there. So that's what we got going on here. Let me run that and create a transaction table. Again, just in case we don't have pandas defined, I'm going to import it here. If you pop around cells in a notebook, sometimes you get in trouble because packages aren't imported and you get errors. So it's not even a bad practice to, on different cells, just include the import statement as well. I'm not doing it everywhere here, but it does save you if you want to be able to sort of selectively jump around your notebook. Now I'm going to be using the pandas PD, read CSV file, and I'm bringing in this file. I'm going to be reading in dim_customer.csv. That's going to come back as a data frame. Now I'm saying index column equal false, which says don't add an index column to this, and I'm not going to define a column in my data frame as an index. So that's part of the data frame. So let's run that. And then let's take a look at what are the data types created. The customer key correctly is an int, and our yearly income is a float 64. But all the other objects are just object. It doesn't seem to really try to define what it is. This caused a problem in Oracle. It didn't understand when it saw object how to turn that into a date, or that it should even be a date. So both of these gave me errors. So what I'm going to do is recast the birth date. So I want to say cust_df birth date. That refers specifically within the data frame to the birth date column. And I'm going to use the pandas toDateTime to convert that column to be a date time column. What's going to really happen here is I'm going to be replacing the birth date with this format. Same thing I'm going to do with modified date. And then let's take a look at it through dtypes. So here we have customer key, and notice now we have the birth date and the modified date. And now date time. So we're all good to go for that. So let's take a look at the cust_df data frame. You can see we have 4 rows, keeping this very simple. Everything's lowercase, great. All numbers, notice they're sequential, 11,000, 11,001, 2, 3. It's important later because we're going to do some inserts with much larger numbers, and that's kind of easy to see that it was correctly inserted. We can see the marital status, etc. Also notice the modified date, because that's a way we can check that our transaction updates work. All of the modified dates on these rows, and modified date means when it was modified by the source systems. So there's the idea, 2019 or 101 for all 4 rows. So kind of bear that in mind. We're going to come back to that. Now that we have it, we need to take that data frame and save it to our table. Let's kind of walk through this, but I want to explain something. I got lots of warnings here about if exists replace. I'll explain that now. We're going to say cust_df, and again, a pandas function to SQL. This is one of my favorite functions because in a single statement, I can take the data frame and just save it to my table. The table name is YouTube_customer, which is the table we just created for the master table for customer. We give it the connection, and then we say if exist. Now we're saying append, but we could have said replace. If we said replace, it's going to drop the table that's there and ignore that we created it and create a brand new one that pandas will default to its own column types. So we don't want to do that. We want to keep our primary key, we want to keep our ETL last update column, and our definition of column types. So instead, we can use append. We know the table's empty, we just dropped and recreated it. So we use append, and that will insert into the existing structure. So it's really important. We're not going to make a column for the index. We don't really have an index anyway for this data frame, but index equal false says don't try to create a column for the index. And just to confirm it worked, we're going to do a read SQL query. And here I put a link in for your convenience that will bring you to documentation on the toSQL statement here and the read SQL statement here, so you can read about different parameters in case you have different requirements. So again, looks just like the data frame, only this time, this is the table. We've actually got it in the table. And we can see, notice our ETL last update column is populated for us. We didn't have to insert it. It automatically happened because we defaulted the value. Another idiosyncrasy with Oracle, which is it does not support the SQL Standard Information Schema. It does, however, have a database catalog. So instead, they use their own tables to do the same kind of thing. And they have one called all tables. There's a whole bunch of different tables for doing this. We're going to query all tables. We're going to get the table owner and table name. And we're going to say where the owner is HR. That's the user that created it, which is us. And the table name is YouTube customer. And notice I'm using all uppercase because that's how Oracle will, by default, consider it. And I'm going to order by owner and table name and just run that and get back YouTube customer HR. So we confirmed it really did create the table. The next table we need to create is the transaction table. So again, PD read CSV, and we're going to be reading in dim customer transactions.csv. We're not going to worry about using an index column, right? And we're going to load that into transdf. And then here, again, we have a problem with the date. We need to take the birth date and translate it into a proper date time stamp format. So we're using the toDateTime here. So we'll run that, and then we can take a look here, and there's our transaction data frame. Okay, so we're going to take transdf, and we're going to say toSQL to create our table. We're going to create a table YouTube_custtrans, give our connection. Again, just like before, we want to keep the existing table. So we'll say if exist append, and then we're going to say index equal false because we're not going to use indexes. We don't want to save an index column as a column in the table. And then we'll just do our read again to display it. Now let's walk through what our transactions are before we use them. If you can see here, we've got two keys which we know exist. We saw that before. And we're saying here we want to do an update. Notice the modified date is not the same as what we had before. The existing date is 2019-01-01. The new ones are 2020-01-01 and 2019-02-01. So that will be a way to tell it did do the update. We also see two really large key values that we don't have on our table. So these are A's for add, so those will be inserted. And finally, I have one that exists, 11002, and this is a D for delete. So again, this column isn't critical, but we are going to use it a little bit. But the main point of this column is so it's easy for us to see what we're doing so you can follow how the transaction was applied. Let's take a look at the definition of columns in the transaction table. In other words, what is the meta structure? Just in case you want to do this. In this case, we do sys all tab columns. That's the table name because we don't support information schema, owner equal HR, and we give it the table name. We run that. And I just want to show you this because it can be handy. Like, did it really create this? Did it do what I want it to do? And this shows you it actually did. So let's look at what we need to do for this transaction to be applied. So we're going to take the transaction table and apply it. And we're going to do an add if the customer key is not found. Then we're going to insert. If it is found, then we're going to update. However, if it's found, but the action indicator is a D, then we're going to remove the customer rows. So here's doing the upserting. I should really merge, but I called it an upsert statement. And notice in the update itself, I wanted to show you you don't need to update every column. You could have hundreds, maybe even thousands of columns in some tables. And if you don't necessarily need them to be updated, you can save a lot of overhead by not doing an update. In this case, birth date's a good example. You would, in most cases, not expect people's birth date to change. Now I'm going to create the SQL statement first as just a string, and then we'll execute it. It starts with the merge keyword. Something you don't see in the SQL Server one, if you follow that video, is the into. You need to include the word into, and then the table name that's going to be updated. In other words, I'm going to tag that as target. We're going to be updating our master table. Then we say using, and the idea of the using is saying this is the source of the updates, our transaction table. We could just put in the name of the transaction table, but I want to show you that you can also include a select statement, which can have varying degrees of complexity to suit your needs. So we'll identify that as source. Now this is crucial here because this says on the source customer key equal the target customer key. So it's going to be matching the source to the target, and that gives us our conditional starting point. Did it find a match? Did it not find a match? So we're going to say when it did find a match, when matched, then do an update. And it's going to say, okay, update the last name, and that automatically means from the target, our master table, update it with source last name. Update marital status with source marital status, etc., etc. Notice ETL last update, though, we're going to use a special reserve constant or variable in Oracle called current underscore timestamp. So that will automatically plug in the current date time for the ETL last update, replacing whenever it was first inserted. Now this is an interesting thing. We can actually handle the delete as well. In this matched, it was matched, we can add a delete statement and say where source.actionIndicator ind is equal to, in quotes, D. So that'll delete it only when the source transaction table said this is a D. Now you might ask, well, why did I do this upper thing around it? I did that just in case the transaction table actually came in with a lowercase d. They really meant it to be uppercase, but maybe it's manually created and they made a mistake or something. So it's a good idea to do things like this to protect yourself from potential nuances and errors in the data you've got coming in. So that's why I did that. Now this is a very strange thing because on the one hand saying when matched, then do an update, and then you add this extra piece here to do the delete. So it's a bit odd. This should work. So hopefully that's all good. When not matched, then we just insert everything. And in this case, notice where we stop here, we don't have an ETL last update date. That's going to default, but we just insert all of these columns. First you give it the column names, and then you just reference all of those from your source. And that's about it. I'm going to run this and do a print so we can see what it looks like before we execute it. And here's where another nuance came into the Oracle side of this. I found it very difficult to get Oracle to commit the changes. Now I don't know SQL Alchemy side or whatever, but something was going wrong and it wasn't committing my changes. What I discovered was you need to create a connection and close the connection when you're done to actually force it to do the commit. Played around a lot. It's very quirky how Oracle works with this, but let me walk through what I ended up doing. I'm going to start by creating a brand new connection, and then I'm going to use my function to create the Oracle connection. I could use the connection we have, but it will close it when I'm done, and then I can't use that connection. So I'm going to create a brand new connection with a function, and then I'm going to run a with statement. With statements are really powerful statements. They're usually considered best practices when they exist. They're often used with files that you want to pull in. For instance, imagine you want to read in a CSV file manually. You want to read in row by row. A really common practice for that is to say with and then read in the file, because at the end of it, a with statement automatically closes the file. So it eliminates the possibility you'll forget to close a file. Fortunately, we have a with statement that we can use with our connection. So we're going to say with a con merge connection we just created, and then we're going to do a begin, and that says begin a transaction. And that's a way of starting a transaction, and that means that Oracle is going to be tracking what you're doing, and it's going to wait for something to tell it to commit the transaction or roll it back if it failed. So we're going to say begin, and we give it a new name when we do that called con merge transaction or con merge trans, which we're going to refer to in our code. And then we're going to say, like before, tried to do this. Con merge trans, execute our merge statement, right, in the SQL string. Now, if it fails, it's going to come back and say error processing the merge. Typically there you can do a rollback or something. I'm just going to give you that error message. So let's run that. Let's walk through and see, did it really do our updates correctly? A point of reference will be our customer transactions. So here they are. And this is our customer master file to see how it looks afterwards. So the first thing we should see is that these two got updated. Well, we see, remember the modify date, now it says 2020-01-01, so we know that got changed, and this is 2019-02-01, so we know that did get updated. We can also see our ETL last updates are changing. Then we see, notice that we had the delete, right, 11002. Interesting, that was a D. That would be, because we're sorting by customer key, that would be between 11,001 and 11,000, let's say 11001 and 11003. It's gone, so the delete worked. And then finally, we should see these added as they are. See that we see these two rows. Those weren't there, so they were added. So everything worked as expected. Now that we're done with that, we need to close, or what they say here is dispose of our connections. That frees up resources and threads to go to the database. DBAs don't like it if you don't do that, so let's keep them happy. Wrapping up, we started this video by talking about what is a merge and why do you care. I did kind of diagram to show you the idea. We have a master table that was maybe taking a snapshot a while back, and we need to update it. And we talked about that we need to do an update, and I talked about the overall transactional process structure. But then we jumped into the merge statement itself, and we saw that the merge can do insert, update, and delete all in one nice little statement. It's very intuitive if you do ETL work, the way the merge statement is worded, because you typically do that. You match the keys, and then you say, okay, drop this or update this, insert that. So it's really a powerful way to do it. If you have trouble getting this to work, because I do know it's a bit quirky, then just go back to using insert, delete, and update statements separately, and I'm guessing you'll have a better luck with that. We also did a riveting demo where I walked through all of what you need to do and how the statement works, and talked about the sort of idiosyncrasies of using Oracle with Python, all right, and SQL Alchemy. That's it. So please like, share, subscribe, comment, let me know what you think. And until next time, I'm pulling for you. We're all in this together. Thank you.